Hello everyone, I Himali Pathak, final year student of Department of Civil Engineering, Faculty of Engineering and Technology, going to present my seminar presentation on the topic Strength Improvement of Fire Damaged Concrete. So basically with this presentation, I will be telling you how we can improve the strength of fire damaged concrete. Here is a table of content. These are the topics I will be carrying out. First, introduction, effect of fire on material, method of repair and retrofitting of fire damaged concrete, methodology, case study, and then conclusion. So here we go with the introduction. As we all know that fire in building is increasing day by day. As being a civil engineer, fire incidents, assessment, repair of fire damaged structures has become a topic of interest for us. It is a structural engineering challenges for us. As we all know that concrete is a non-flammable and does not emit poisonous gas. Unlike steel, when subjected to temperatures of order of 700 to 800 degrees centigrade, concrete is able to retain sufficient strength for reasonably long period, thus permitting rescue operations for reducing the risk of structural collapse. Here is the effect of fire on material. The first is effect of fire on hydrated cement paste. If the rate of heating is high and the permeability of cement paste is low, it damages the concrete in the form of surface spalling. Effect of high temperature on aggregates. As aggregates normally occupy 65 to 75% of concrete volume, and that is why the behavior of concrete at elevated temperatures is strongly influenced by aggregate type. Commonly used aggregate material are thermally stable up to 300 to 350 degrees centigrade. Effect of high temperature on concrete. Due to increase in temperature, the concrete loses its workability. High temperature can cause cracking and spalling due to thermal shocks. The fourth one is effect of fire on reinforcement. Strength and modulus of elasticity of steel are re-decayed by nearly 12% to 14% when exposed to 482 degrees centigrade temperature. Beyond this temperature, there will be reduction in yield strength and modulus of elasticity on reinforcement. The fifth one is that is last one, effect of fire on color of concrete. To evaluate damage to concrete exposed to high temperatures such as in fire, we first observe the change in color. The reason why color changes into red is that iron is aggregate dehydrated or oxidized due to high temperature. Here is a table which will show you the temperature ranges and the effect on color. If the temperature ranges from 300 degrees centigrade to 600 degrees centigrade, the effect on color will be normal pink to red. 600 degrees centigrade to 900 degrees centigrade, it will be whitish gray. 900 degrees centigrade to 1000 degrees centigrade, it will be buff. Beyond 1300 degrees centigrade, softening and melting of surface layer. Here is a method of repair and retrofitting of fire damaged concrete. The first one is fiber reinforced polymer. Fiber reinforced polymer is a synthetic material in which polymer matter is reinforced with fibers. These materials have high ratio of strength to density, exceptional corrosion resistance, and convenient electrical, magnetic, and thermal property. Here is a fiber reinforced bar. Second is concrete jacketing. Concrete jacketing is one of the most common retrofitting method for structural members. In fire damaged building, concrete jacketing may provide additional strength to damaged structural members. It is most common in India. So this figure shows you the concrete jacketing in column. Here is steel jacketing. The steel jacketing reinforcement method is a reinforcement method in which steel section, that is usually angle steel, is wrapped around the four corners or two corners of member to enhance its force bearing performance. The steel jacketing method can greatly increase the bearing capacity, increases the ductility and rigidity of component without basically increasing the size of component, and the force is more reliable. The figure shows the steel jacketing of column. Here we go with the case studies. The first case study, this case study I have taken from a research paper. The name of the project was Fire Damage Assessment and Improving the Performance of Concrete Exposed to Standard Fire Temperature. The place was Karunya Nagar, Tamil Nadu. Viewpoint of the project was strength improvement of fire damaged concrete. The conclusion of this project was the comprehensive strength increases to 102% to 107% from the original strength of the sample for M40 and M50 specimens respectively. Here is a case study too. The name of the project is Deterioration Assessment and Rehabilitation of Fire Damaged Concrete. The sample size was 100 to 200 mm HSC cylinder. Maximum temperature was 600 degrees centigrade. Heating rate was 5 degrees centigrade per minute. Compressive strength was 15 to 91 megapascal. Water content ratio 0.22 to 0.57%. Here is the third case study. The name of the project was Fire Damaged Assessment of Reinforced Concrete Structures. Name of the study was Optical Microscopic Study. Location was RCC column C32 and slab S1 and slab S6. Instrument was used was stereoscopic microscope Nikon SMZ 1500. Condition to determine the various microstructures. Result inference were drawn to establish the deterioration development caused on of the fire. Here is a microscopic image of fire damaged concrete. First one is void is filled with crystalline material. The second one is leached out material has been observed. The third one is void filled with crystalline material. And the last one is stretching of coarse and fine aggregate due to temperature rise. Here is a conclusion. So we have concluded that RC structures generally have adequate fire resistance, but analysis of influencing factors such as concrete type, component geometry and dimensions and imperfections can improve fire resistance. Thank you.